Welcome everyone. In this video I'm going to show you how to connect a digital readout DRO to your Arduino and show the numbers on an LCD screen that you can see here, or send the data to the computer and process it there. So as you can see, there are three main components here. We have the DRO. This is a Chinese DRO, JCS-900. So you can see that we have the electronics in this upper part here, and then the scale or the ruler is inside this metal part. So then when you move this part with the electronics, then you can measure the displacement of it. And some more details about this. So we can measure 5 centimeters or 50 millimeters of displacement with this, and the resolution of this unit is 5 micrometers. So we can divide the 5 centimeters into a lot of steps. So this is very good if you want to measure displacement on a small distance with a nice resolution. And there are also units which can measure the displacement with 1 micron or 1 micrometer resolution, but they are more expensive. And the output of this unit is 2 square waves shifted relatively to each other, and then by processing these square waves you can get back the data. And it is operated at 5 volts, so you can directly power it from the Arduino. So what we have here at the other end here, this is a 9-pin D sub connector. So I have something like this, or not something like this, exactly this, and I soldered all the 9 wires, and I tested each wires to see which one is the output and which one is the power. And luckily it's very simple. The first 2 pins, so on the top, so basically the 1 and 2 are for the power, so the grounding 5 volt, and then the next 2, so the 3rd and the 4th pin, are the output pins, so they provide the square waves shifted relatively to each other, and that's all. We don't need other pins or connections. So you can see I connected 2 wires to the power. So the first pin or the first connection goes to the 5 volt, and then the second connection goes to the ground, and then the next 2 are connected to the pin number 2 and pin number 4. This is important because the Arduino will be programmed with a software which uses interrupts, and there are limited number of pins available on the Arduino which can be used for these interrupts. And one of these pins is the pin number 2, so we have to attach it there. And then we have the LCD screen, 16 segments or characters and 2 lines or rows, and it is using the I2C connection. So basically you need just 2 wires for the data, so data and clock, and then 2 wires for powering, and then this small potentiometer is for the contrast. And this circuit is basically this on the black PCB is what translates these lot of pins to I2C. So most probably this chip is corresponding for this task. So that's all. we have the DRO, which provides the square waves. We catch those square waves and process it in the Arduino, and then we send the numbers to the screen and to the computer via the USB cable. So now I power up the Arduino, and you will see a startup sequence, or sort of, on the screen, and then we will see how this DRO works. So it is starting, and then now you can see that the position is 0. You have to know that this is a relative displacement. So as you can see, this is now at a random position. So whenever you start this, you have to know where you start. So I strongly recommend you to put it in a position that you know. So for example, in the start, where you cannot move this scale anymore, and that will be your 0 position. But whatever you do, you have to like hard code and mechanically decide where is your 0 position. So this is not measuring absolute, but relative displacement. So it's not like a ruler or like a caliper. So now you can see I moved this, so it changed the position. And now I start to move it very, very slowly. And now we are, okay, now we are standing at 10, and I start to move it. And you can see that the numbers are rapidly increasing. But you have to know that after a certain speed, so if you move this scale with high speed like this, the software is not able to process or not able to see the square waves, or the hardware, I don't know exactly, but the thing that is happening, that you cannot generate and process the square waves that quickly as you move this head here. So therefore you will not see the precise displacement. But on the other hand, this thing is not designed for quick movements. For example, this is usually built in milling machines, and you know that if you try to move the table or the z-axis of a milling machine, that is a relatively slow process. And then this device can perfectly follow that. So if I move it very slowly, so now I just compress or press this cable against this head, so it goes very slowly, and you can see that the numbers are going very nicely. And now you can see that it is now 65,000 something. That's because I only work with positive numbers. Therefore, if I go towards the negative, the variable in the Arduino will overflow, because I defined it like that. But you can change this in the code and define your number even as a double. I have a unsigned int, like integer, so this is why it is overflowing. But you can see that the numbers are very, very slowly changing. So it's very nice. And also you can see a bug, but it doesn't matter now. So I forgot to include the clean command for the LCD screen. So if you have something with 5 digits, and then suddenly your number for some reason is changed to a 3-digit number, then the last 2 digits are still on the screen, because I just print the numbers as they are, because I just put together a simple code just to show you how it works. So when I show you the code and some explanation based on this DRO, I will correct this mistake. But what I wanted to show you is just that this works as it should. And now I will try to connect this to oscilloscope and show you how the signals look like. So now what I did, one pin or leg is connected to the ground and the other is one of the inputs. So whenever I move this thing, it should show you a series of square waves. So I hope it's visible. So there was one wave, but I tried to move it more. And you can see there is like a series of square waves. So you detect these. And when you get these square waves, basically you count them, and each count is like 1 unit of displacement. And you can see how it goes. And if you move it with a stable speed, then the square waves will also look a bit better. And now I will move it like suddenly. And you see that this is just like a few steps of square waves. But in reality, this was like 1 centimeter. So it should be more, because now I move like a few millimeters. And you can see much more square waves. So therefore you can see that something is wrong if you move it quickly. But we could see the basic process, how to wire up everything and what are the limitations or problems. So now I go to the computer, show you some stuff based on this DRO and show you the code. So you will be able to process the data for your own DRO. So we are here at the computer and you can see that I started the Arduino software, and this is basically the code for our signal processing. So I just did a small calculation. So the length of this DRO is 50 millimeters or 50,000 micrometers, and then the resolution is 5 micrometers. So within the 50,000 micrometers we have 5 micrometers steps, or the steps are separated by 5 micrometers. So this allows us to distinguish 10,000 different positions. So if you move from the position, or from the initial position to the final position, the number should be 10,000 at the end. So we define 2 pins, the pin A and pin B, and that is connected to 2 and 4 on the Arduino. As I said, one of the pin, the number 2, should be connected to this pin, which is able to which you can use with this interrupt function. And then we have this encoder position. Now I corrected it. Previously it was unsigned int, as I said in the previous part of the video, but I just removed the unsigned, so you will see when I connect it to the terminal that we can handle the negative numbers, but it doesn't matter. And I made a switch. I will show you why, but I really like to use booleans to make them into like sort of flags, so you can handle your software more easily. And then we need the wire library for the LCD screen, and also the LCD screen itself has its dedicated library. So we load that, and here we can also see that it's 2 lines and 16 characters LCD screen that we have. So we move into the setup. So of course the pin A will be an input, and also we pull up to the high level, and we do the same with the pin B, so the second pin. That's all. And we make this pin number 2 into this interrupting pin, you can see, and we will start a function or method which is called do encoder whenever there is a change on this interrupting leg. We start the serial, we print some random message, and then we also start up the LCD screen. And then this is just my fancy startup sequence. So basically I just print a loading screen to increase the number of dots after the starting word here, but this is just my own thing. And at the end I just have this screen. So on the upper part of the screen you will continuously see the text DRO scale, and then in the second line you will see the position, and after the position you will see the numbers. You have to make sure that if you have a lot of digits, then you will not be able to fit in the second line or whatever line of the screen. So keep in mind. And just a small explanation about the set cursor. So if you have a 2-line screen, then 0, 0 means that you start at the 0 position and in the 0th line or first line physically. And then 0, 1 means that you are in the 0th position and then in the first line or second line. But you know that in programming everything starts from 0 and not from 1, so this is why it is 0 and 1, which is in reality then this is the first row, let's say, and then this is the second row of the screen, and also like first place for the character, and this is also first place, and you can understand better. So this is all, and then we have the loop here, but now let's just see the encoder stuff. So you can see that if something happens here, so there is an interrupt, so basically we have a square wave coming in and it's detected by the Arduino, then we compare the two signals, and then we see that if we move it in the positive direction, then we add one number or we increase the value by one increment of the encoder position 0, so this, or encoder 0 position. But if it goes to the other way, then we decrease the position or the value of the variable. And then I also make this flag or change it to true, because we had a new data, and then we print it on the serial as a decimal. In fact, this should not be here, we can move it into the loop, but now it's here. And then we don't want to slow down the processor, and we don't want to refresh the screen continuously, because it will cause blinking, so it will not look nice. So therefore, if there is a new data, so when this function is triggered, then we clear the screen, so we get rid of everything, and we print again everything. So for example, that mistake what I told you when I demonstrated the screen will not happen. So if you have 5 digits and then somehow you end up with only 1 or 2 digits, the remaining digits which were on the screen previously will be erased. So this will not happen. And So we print out the previous message in the first line, and then in the second line we print out the position, and you have to count down the number of characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And we know that we start from 0, so the 10 here where we put the cursor is in reality is 11. So we start from the 11th position. So if I put the cursor here, no, I show you. So we print this on the screen position, sorry, and then we have this, and then we put a space, and then we start to print our number. So this is where you see the cursor now. That is this 10th, or in reality 11th position. So we print that encoder value from this position, so where you have the number 4. And then we switch back the new data to false, because if it stays true, then this loop will continuously run, and then the screen will be always refreshed, and you always get the data on the serial terminal, and you want to avoid that. So now I start the serial terminal and I show you how it works with the data. So here we are. So we have our first message, this guy here, and we are done. So I just have to move with the you can see I move the scale, so the numbers are increasing, and now I move it in the other direction, so they should decrease, as you can see. And now I want to move towards the negative. There you go. So we are in the negative region, but we don't need this. So in fact we will always start from one of the edge of this scale, so that will be the 0, and we will not move over that. So that is like the absolute 0 position if we set it up like that. And if the resolution would be larger than the current resolution, then we might need the whole range of the integer, so this 65,500 and something. Because if we have negative numbers, we just use the half of the range, so we have like 32,000 something numbers available. But since we don't need it, it's not a problem to use just half and have the negative numbers as well. And you cannot see it, but I'm just moving this with a very, very fine movement, and you can see that the numbers are increasing a lot. So if I would move this across the whole range, the 5 centimeter range of this DRO, we would see that actually we can reach 10,000 at the end with the numbers, because now I basically moved like just a few millimeters and we are at 500. So this was the tutorial about the Arduino part of the DRO scale. So I hope that it was simple enough. I will upload the code as it is usual, and I hope you learned something from this, and see you in the next video.